Hello, everybody. We're looking at a sample here that was sent in. It's a flake, which actually gets made up of many layers of smaller flakes. As we see, we've run about 20,000 particles in a matter of a few minutes. We basically have information for mean size. We have standard deviations for size, assuming that it's spherical, but we also have a broader range of many other shape parameters, including smoothness, which we'll look at. We'll look at aspect ratios. But just to give you an idea of what these particles look like to begin with, what I generally do is I'll go in and I'll make sure there's no limit selected, and I'll just do a thumbnail preview of all the particles. That allows me to see just visually what are the two different or three or four different types of populations. So as we see, we have some particles that are flake-like. Maybe these are flakes that are with the broadest face toward the camera. But we also see that there's some possible flakes that maybe are in their side view or in angle views. So we see a lot of high aspect ratio particles and low aspect ratio particles, kind of indicative of flakes. And being that the particle insight does try to enforce random orientation, you're going to get all three dimensions of your sample. We also see a few bubbles here. We can actually ignore those and reject those as well. But for the most part, as I go through all 20,000 particles, I'll see that for the most part they are either non-high aspect ratio particles or they are higher aspect ratio particles. And by looking at them, I can, looking at these blue numbers, which I selected to be aspect ratio, I can see that most of the particles that have an aspect ratio of, let's say, 1.9 or greater seem to be the particles on their side. What we can do is we can actually go in and just see the particles that have the, let's say, the low aspect ratios, let's say 0 to 1.9, and then look at the thumbnails. And we'll see, we shouldn't see many of those stick-like particles or side view particles. We'll see a majority of the ones that are with their broadest face toward the camera, including those bubbles, because the bubbles obviously would have a lower aspect ratio. We can also go in and look at just the sticks. Let's look at the particles that go from 1.9 aspect ratio to about 10. And we can do that as well. And if we feel comfortable with this, let's just verify that that's a good limit to draw between the side views and the front views. Then, and that's pretty good. Maybe some of these aren't. Maybe some of these happen to be particles that are not completely on their side, but maybe on their way to being rotated to their side. We can actually maybe increase that aspect ratio to exclude some of these particles that are on their way to rotating to their side views. Let's say we increase our aspect ratio limit to, let's see, let's make it let's make it 2.2, let's say, and greater. Let's just say 2.0 and greater. So we'll look at all aspect ratios, particles with aspect ratios 2 and greater, and at the end of the day, what we're trying to do is define the line of what we think are particles on their side or not. And once we determine that that's what we have, we can actually go in and do a couple of things. We can actually go in and see what how much of my sample shows up with an aspect ratio of 2 and greater. We can see that. And by doing that, we could do it via reports, or we can do it here in this large preview, or we can just go in and say anything, let's say 2 and greater, 2.1 or 1.9 and greater. We look at the statistics just for that. We can see what percentage. We found 7.66% of the entire population has an aspect ratio greater than 2.3. Let's say we don't want it to be 2.3. Let's make it 1.9. So here we have 16.2% of the entire population has an aspect ratio greater than 1.9, which would be the particles on their side. We could see what their mean width is, 2.57. Of all the particles that have their aspect ratio greater than 9, the mean width is about 2.5. The mean aspect ratio is about 2.57. Now what we can do is we can actually create data just on these particles. What we can do is we can actually go in and look at many of the different shape parameters, like aspect ratio, let's say, opacity, whichever. we can go in and say, I would like to make sure that I only want particles that have an aspect ratio of 1.9, but I would like to actually recompute data and graphics. So this is actually useful because what I can do here is I can eliminate particles that have an aspect ratio less than 1.9. And by doing that, then I can find out what the mean size is, what the mean width was, based on the gating factor of aspect ratio. So I'll go ahead and I'll recompute statistics, and we're going to see that these graphs all change. These graphs now eliminated particles that had an aspect ratio less than 1.9. And then we can see, let's say we want to see what the mean width was. So let's look at bounding rectangle width. And we can see that all the particles that had an aspect ratio of greater than 1.9 had a mean width of about 12.7 microns. Standard deviation and mode D10, D50, D90. That's one useful feature in the Particle Insight. We can just analyze with 30 shape parameters all of the particles, only the ones we were interested in. If we want to go back and bring those other particles that we eliminated, we had 20,000, now we were only analyzing 3,200. We can reopen the existing file, go back to the existing file, and here we're back to the existing file. And we can do a couple other things. Something else that I found very interesting with this sample is with the larger particles, I wanted to find out as the particles, let's take the particles that had they were not stick-like, so the particles that were facing the camera, going from aspect ratio of 1 to 1.9. Let's say I wanted to find out how as their size is getting bigger, are they getting smoother? Is a good question. So we can actually do a correlation plot and see if we have any interesting information. And we can see smoothness here and size here. So here we basically show that there is not much of a correlation, but actually the scatter plot tells us a lot. Here, just picking something out of random, these are for the particles that are only with the largest face toward the camera. We can see that we have two populations. We have particles ranging anywhere from about 70 microns down to about 3 microns. And we have smoothness, one being perfectly smooth. I would say that these that are way up here, actually close to a 1, I would say these are probably bubbles because they're very round. If we wanted to look to any section, let's say we wanted to find out what were these particles that were, let's say, between 30 and 100 microns with a smoothness of less than 0.5, we can go in and say, okay, well then only show me the particles that went from 30 to about 100 microns with a smoothness of 0 to 0.5. I will deselect this, and then I can actually look at the thumbnails for those particles, just those particles that are of interest, and we can actually give some attributes to those particles in specific. And we can see that some are bubbles, but some are actually particles with their largest face forward. So anyway, that's pretty much all I found on this sample. We can actually do this live and go over some more information. But that's about it. This is the Particle Insight, and we're just looking at these samples, and thank you for your time.